Certain types of cyanobacteria, like microcystis, produce trace amounts of odorous chemicals and toxins, which lead to water pollution. Managing their populations, thus, is one key measure needed to ensure water quality. This requires the use of prediction models for cyanobacteria blooms, such as the Environmental Fluid Dynamics Code, or EFDC, developed by the National Institute of Environmental Research, or NIER, South Korea. Prediction models are reliant on values called initial conditions, such as the population of cyanobacteria at the beginning of the time period being modeled. This initial condition is particularly significant while performing short-term predictions. However, existing techniques to determine initial conditions involve the measurement of the levels of various chemicals in physical water samples and are not very precise. Hyperspectral imaging, a remote sensing technique, can identify different chemicals in river water based on images taken by drones, which allows for the accurate estimation of algal populations in that water. Recently, researchers from National Institute of Environmental Research South Korea developed an optimal method to obtain the initial conditions of EFDC-NIER modeling using hyperspectral imaging. They collected hyperspectral imaging data for a part of the Nakdong River Basin, where microcystis flourishes in the summer months. They then applied this data to the EFDC-NIER model. They also performed EFDC-NIER modeling using initial conditions obtained from physical water samples procured from different points along the river. Upon comparing the two sets of modeling results, they found that hyperspectral imaging could provide more detailed initial conditions for the model, which ultimately reduced the uncertainty in the modeling results. Using hyperspectral imaging to predict initial conditions not only improves the quality of the predictions, but also enables the estimation of algal populations in inaccessible river areas, leading to more accurate and representative results.